All right, here's our bell work. So just like we saw in the last unit, got to do some distribution right here. So that's what I'm going to do. Negative 9 times 4x's would be negative 36x's. And then negative 9 times 3 would be negative 27. Of course, we didn't really do anything with the rest of those terms right there. So this is what we got now. Now, the next thing I would look to do is to combine any like terms, and I see the negative 27 and the negative 25, which combine to be negative 52. But also the 18 plus 2 on the right side would be 20. All right, so I still got the negative 36x minus 52 equal 20 here. But then I see all my x's are on the left side of the equal sign, so I'm just going to keep them there. I'm just going to zero out this negative 52 by adding 52 to both sides. And that's going to zero out just like we want. I'm going to drop the negative 36x. This is going to equal 20 plus 52, which is going to be 72. Now, when I go to divide both sides by the coefficient of x, which is negative 36, I get a phantom 1x. X equals 72 divided by negative 36 is negative 2. Now, I'll just go to my calculator and check. So I know 18 plus 2 is 20, but I'll type in negative 9 parentheses. That's 4 times negative 2 plus 3, close the parentheses, and then minus 25. Enter, and I get 20. So that would indicate that we actually have found the solution to this particular equation. So we're going to be dealing with equations still in this unit, Unit 3, which is 2 lessons long. But you'll see that we're pretty much doing everything that we did in Unit 3, or Unit 2, but with maybe small exceptions. So here's our objective. I can solve and graph inequalities. Just take 30 seconds and copy that down, please. An inequality is a math sentence that compares quantities. That's true, just like an equation does, by the way. But the comparison is slightly different now. All right, now remember with equations, okay? So with equations, we said usually if there's one solution, we'd say, hey, x can equal, I don't know, 7. All right? And then you can kind of check that answer, but there's only one answer that would make an equation true. All right, now, instead of comparing it, x's with just one number, we need to compare it with lots of numbers, right? Because in the equation we saw, and yes, it's possible to have infinite solutions or no solutions, but usually we saw one solution. But now we're going to be comparing x perhaps with, it's still comparing with one value. So you could say x compared, let's compare with 10. But now let's say that x is greater than 10, like this, okay? Now, of course, if you replaced x here with 10, you'd get a false statement. But we're saying that x is anything bigger than 10. So what's bigger than 10? Well, you'd say 11, you could say 12, you could say 13, and you could go on forever from there, but that's just including all the whole values. You could also include decimals, like 10.0001. That's greater than 10. Or, I don't know, 50/4, okay? That would be greater than 10 as well. So you include all the fractions, and so with inequalities, we generally end up with an infinite number of answers, which is why we have to show it in a more simplified format like this one. Okay, because we don't want you to have to write out all those values as an infinite number of values, and the only person we think is capable of that in this life is Chuck Norris. Because it's possible that you can get less than or greater than. So these are, I think, symbols that we've seen before, at least the first two right here. This is the less than symbol, and I say that it's less than symbol because it kind of looks like an L. I don't know, you decide. And then we got this other symbol right here, which is the greater than symbol, which I say it kind of looks like a G as long as if you just add a little hook right there. So whatever. However you remember that one is less than and one is greater than, that's the important part, okay? Now we're adding a couple extra symbols here, so you'll see this is the less than symbol right there, but it's got a little mark down beneath it. That's to indicate that it's not just less than, but it could also be equal to. And of course, you can't have these both at the same time. So you can't have something that's less than and equal to, which is why it's an or statement right there, okay? Which is crucial because we can compare values that are less than, and that would be true. But if they were equal to, then it would be true. It could make that statement a true statement too, okay? So the little mark underneath it just indicates that not only could it be less than, we're saying that if it's equal to, that's okay too. Same with this one right here, so that's a greater than symbol right there, but it could, if it's equal, that's fine. We would still indicate that that would be a true statement. For these symbols like this, okay, you'll notice that we get to use a symbol instead of writing out full-blown words like this, or even like a full-blown statement like this, okay? And I don't know about you, but I'm not a huge fan of writing all these words out. Maybe it's because I'm a math nerd, but this is kind of where math becomes a different language or even hieroglyphic in nature, because we get to use these symbols like this, like these, to replace what would be words. And so we can write things shorthand with some math symbols like we see right here. So we got to see these principles of equality because we're going to be using them throughout with inequalities, okay? So addition and subtraction, remember, we use addition and subtraction to make make zeros rather. And then we use multiplication and division to make ones. And usually that's just with the coefficients, okay? Yeah, we'll write this in here. That's for the coefficients. Just like we saw on the bell work, when we need the coefficient to be a 1, we generally use division to make the coefficients of the variable phantom ones. And that's why we're looking at zeros and ones right here, because zeros and ones become phantom values. Zeros with addition and subtraction, and then ones become phantom ones with multiplication or division. So there is one tiny extra rule for solving inequalities, but for the most part, you're just going to be dealing with this straight across. And the one extra rule occurs right at the very end if it needs to happen. Okay, so it won't always happen, which is kind of convenient. So remember, solving equations, we kind of have this this strategy for solving equations. So you'd always distribute first, if you can, like we did in the bell work. Then you'd combine like terms, if necessary, which we saw in the bell work too. Then we use principles of equality. That's where we make zeros right here, phantom zeros. And then the fourth step right here is to divide both sides, essentially by the coefficient, because at that point you should have all the x's on one side and all the numbers on the other side. Well, solving inequalities, you can see, is the exact same process. It's just at the very end, you look at the coefficient. If it's negative, then you got to flip the inequality, okay? And that you would do that either before or during the division phase of the strategy right here. So again, that occurs right at the very end. You just check to see if that coefficient's a negative. Now, some students prefer to think of it as if you ever multiply or divide both sides by a negative, then you flip the inequality, and that's true as well. It happens the same way. It depends on how you want to look at it, and that'd be fine if you did it that way, okay? So nothing changes here. It's just at the very end, if the coefficient's negative, we'll flip that inequality. So let's look at this one. We got a couple statements there, just throw it away. And then we got 7k is less than 35. Now, on this one, we're just trying to determine if it's true or false. But if I replace the k here with 5, then I'd have 7 times 5. And the statement is showing that it's greater than 35. So I'm going to put a question mark over the inequality here. And I'd say, well, 7 times 5 is 35. And then I'd say, well, is 35 greater than 35? And the answer to this one is no, which makes this one false. Okay? So that's looking at an inequality that we may have seen before, something like this before. Because if I replace k with 5, it's equal, right? We get an equal statement, but this is not telling us that equality is okay on this. But if we go to the next problem, so now it's 7z is greater than or equal to 35. But now if I go into this equation right here and say, I'm going to replace the z with the z value it gave us is 5, then it would show 7 times 5 is greater than or equal to 35. Okay, so here again is a question mark, and then 7 times 5 is actually 35. So we're comparing 35 with 35, but again, the statement says, is it greater than or equal to 35? Okay, now remember, this is an or statement right here. So even though 35 is actually equal to 35, the first statement is false, the greater than symbol, but the equal to part is correct, which makes this one a true statement. Okay, remember, it can't satisfy both. It can't be greater than and equal to. It only has to be one or the other. And in this case, it's the one, which it is equal to. So you have to keep that in mind when you're looking at these equations, especially when you're solving them. And for the most part, since you've seen that we use principles of equality, when we do that, we are maintaining equality. So we're pretty much treating these like equations until the very, very end. Like this one, solve the inequality, right? 5x minus 13 is greater than negative 38. So yeah, let's go ahead and solve this one, but just regular principles of equality. And I got all my x's on the left, so I want to keep them there. I just don't want anything added or subtracted to it. So that's a principle of equality to make a 0. I'm going to focus on that negative 13. I can make it a 0 by adding 13. Okay, but remember, it is a principle of equality. So if I do it to one side, I still need to do it to the other side. Now, principles of equality, addition and subtraction anyways, will not affect the inequality. So that still comes down. It was greater than, so it's going to still come down as a greater than symbol. And then what happens? Well, we'll drop the 5x just like we would in a regular equation. The negative 13 zeroes out just like we wanted. And then negative 38 plus 13, that's going to be negative 25. And the last thing to do right here is, I don't want a 5x on this one. I'd rather have a 1x to compare with. And then I'm looking at using division, the division principle of equality, and the 5 is positive. So that means that this inequality symbol is also going to just drop straight down, okay? And then I'll go ahead and just divide both sides by 5. And again, that's a division by a positive, so that's not going to affect anything. That becomes 1x, just like we wanted. Negative 25 divided by 5 is negative 5. Okay. Now, if you checked in your original equation, you could replace x with negative 5, but you'd find that it's equal to. But it says we need something that's greater than negative 5. So you could check like 0 or even like 1,000,000 and see if that gives you a true statement, which it would. So it is possible to check these. It's just kind of, you have to check them twice. Once for equality and then once for inequality as well. But x is greater than negative 5 shows that it works. This one we would say when x is greater than negative 5, then it would make the original inequality a true statement right there. So that would be true, right? So let's say we replaced x with 1 right here. So let's say 5 times 1 minus 13, that's going to be negative 8, which is greater than negative 38. The problem with that is that that's only one value, but we need to know all the values, and that's where this statement comes in. We're not saying that x is just negative 5 or even the statement x is greater than negative 5. This is an oversimplified form of saying anything bigger than negative 5 will make the original inequality true, like 1, which is the example you gave. The reason why we focus on where these two statements are equal is because that's where it will switch. Equality will switch where it becomes a false statement to a true statement. So in this case, if you replace x with negative 5, you get a false statement because it can't be equal to negative 38. But the moment you get something bigger than negative 5, such as negative 4, negative 3, negative 2, you can go all the way into the positives, like I was saying, like 1,000,000, right? Like you could test any of those values. Let's say we replaced x with 1,000,000, right? So that'd be 5 times 1,000,000. 5,000,000 minus 13 is 4,000,000 and some change. But that's much bigger than negative 38. So anything bigger than negative 5 will make this a true statement. Again, this kind of simplifies that statement for us, so we don't actually have to look at all the numbers or even think about them for that matter. All right, so that's solving the inequalities, but we also have to be able to graph them. Okay, so solving the inequality and showing x is greater than negative 5 is great, but we also have to be able to demonstrate what that would look like with a graph. Okay, so just all you really have to do is look at the symbols, and you say if, and this is the first thing we would do on the graph. So this is after, by the way, you would you would have solved the inequality. So you got to look at the symbols. If it's just greater than, less than, or greater than, then you're going to use an open circle where it becomes equal, okay? And the reason why we use an open circle there is to indicate that the open circle indicates the value we found would make the original inequality, this is the important part, false, okay? There we go. So the open circle indicates that the value is not included to make the original inequality a true statement. Now, on the other hand, if you end up seeing a symbol like this, greater than or equal to or less than or equal to, then you use closed circles, okay? So don't overcomplicate this. When I say an open circle, I'm just talking about something like this. And a closed circle, it's a circle, but just we fill it in like this, okay? And that would be at the number that makes it true. Because remember, that makes it equal, because when it's equal, that's when it switches from being false to true or true to false. Doesn't matter which way. Now, the next couple questions indicate where the line, which direction the line will go. And the direction of the line will tell us the other values that would make the original inequality true. So if it eats the letter, whatever the letter is, the line will go to the right. If the inequality does not eat the letter, then the line will go to the left on the graph. If you're doing this by hand, you may have to use 3 numbers, like you'll see that I'm doing. But I don't think you're going to have to do that on Canvas for the homework, okay? So again, let's say we looked at the last inequality, right? We got x is greater than -5. So if I was doing this by hand, I'd draw a line like this. I would want 3 values. I'd put -5 in the middle. Now, you got to be careful if you're doing this by hand with negatives, because negatives get bigger to the left. So that'd be -6 there, and then -4 to the right, okay? Now this one, we see that the inequality is not equal to at -5, so that means -5 would make the original inequality false. So I have an open circle at -5, but then I see that it eats the letter right here. It's eating the letter, so that's going to go to the right. Okay, and this is pretty much what the graph looks like. So let's look at all 4 of these statements, and they're all pretty much the same statement. It's comparing x with 4. And so, of course, I put 4 somewhere in the middle. That means 3 would be to the left, and then 5 would be to the right. I'm not going to put all the numbers. But for this first one, I see that x is less than 4. It's not equal to 4, so I'd have an open circle at 4, okay? Because it doesn't have the equal sign with the less than symbol. So I have an open circle at 4, and then I'd say it's not eating the x, which means that this line would go to the left. Boom. Okay? And so this is communicating the same thing as the inequality, just in a different way on a graph. I'm saying 4 will make the original inequality false, but anything to the left of 4 on the number line would make it true. That's what the line will tell us. And then on the next one, is x is greater than 4. So on this one, I see that it's just a greater than symbol. It's not equal to. So again, at 4, let's put our numbers here, 4, 3, 4, 5. At 4, I'm going to have an open circle again. But this one is eating the x, so the line will go to the right. Okay, so it's essentially the same graph. It's just the direction of the line changes because one is not eating the x, one is eating the x. So let's compare these with these other ones. So that's this one in the top right. That's x is less than or equal to 4. So when I put my numbers down, 3, 4, 5. Now at 4, I'm going to have a closed circle. So I just fill it in like this. And then again, this one is not eating the x. So that means the line will go to the left. And then for the next problem, this is x is greater than or equal to 4. So again, it's equal to 4. It could be equal to 4. So when I put my numbers down, 3, 4, 5. At 4, I still have a closed circle, but now since the inequality is eating the x, the line will go to the right. Okay, if it eats the x, the line goes to the right. If it doesn't eat the x, then the line goes to the left. Now it's possible you may have heard that the direction of the inequality, whichever way it points, is the way the line will go. that will only work if you put the x's on the left always. So sometimes it may be more convenient to see the x's on the right. Okay, so I'm going to compare to the purple graph right there. So I'm going to switch it, and it's going to mean exactly the same thing. I'm going to compare with x with 4, but see how this one's eating the x? So I could write an equivalent statement where it eats the x. And that's why we want you to focus on if it eats the x, not which direction the inequality is pointing, because if you have x's on the right, then you have to be able to understand. You could just switch it, which is okay, but if you just remember that it eats the x, you won't even need that much, okay? Now, again, if you always put the x's on the left, that would work, but sometimes you guys, at least in the past, students have forgotten to do that. So I'm not going to encourage it, but you could do it. All right, let's write the inequality for this graph. So I'm going to just compare with x. You could use whatever letter you want, but I am comparing x with -8. Now, I am putting x on the left, which I will usually do, but we'll show it the other way with x's on the right as well, okay? But on this one, the first thing I notice is that it's a closed circle right there. So I know I'm going to have the equal part of the inequality. So there's my equal part. I just got to figure out which way the inequality is eating, right? Is it going to eat the x? Is it going to eat the -8? Well, this one is going to the right, which indicates that it should be eating the x. So this would be x is greater than or equal to -8. Of course, it would be okay if you wrote it with the x on the right, comparing with -8. Just it has to be eating the same value. In this case, it's the x. These mean exactly the same thing. For the most part, though, we'll just usually see it like this, okay? And in fact, I think on the homework, it always puts the x's on the left, and then you got to kind of choose which of the inequalities you'd use, and then put the value in a different box there. So solving and graphing inequalities. This one's not too bad. It's just a one-stepper, which I think is pretty nice because I go in here and I can solve for x by just getting rid of that -9. So I'm just going to add 9 right there. If I do it to one side, I got to do it both sides. So that's -16 plus 9, which would be -7 there, which is greater than or equal to. I just dropped the x, and then the -9 zeroed out, just like we wanted it to. Okay, so I'm comparing x with -7, and see how the x is on the right. Again, if you wanted to change that, you could. I'm just going to keep it as is. So I'm doing this by hand, so I'd have to say I want 3 values on my number line. I got -7 here in the middle, so that means -8 would be to its left and -6 to its right, because they are negatives. So the further to the left on the number line you go, the more negative it will be. And I see that the symbol is it's equal to the x. So at -7, I'm going to have a closed circle there. And this one is eating the x, which means the line will go to the right. Okay. So that means everything, every number, including -7, but everything to the right of -7 on the number line will make the original inequality a true statement. Pretty much nothing's going to change after this. Just pretty much principles of equality. Okay, so if we look at this inequality right here, I don't want that divided by 6 with the m. I just want the m, or 1m, okay? So I'm going to multiply both sides by 6 to make that a phantom 1. Okay, remember, if you do it to one side, you got to do both sides. But there's a phantom 1 right there. You can show the phantom 1 if you'd like, but I don't know, 6 times 24, 144. Which, see how I multiplied both sides by 6? That was a positive 6, by the way. So that is not going to affect the inequality there. At this point, I don't really want the 1. I want it to be a phantom 1, so I'm comparing m with 144. Let's go back then. So right in the middle, I'm going to put 144. It's positive now, so to the right will be 145. And to the left will be 143. But the circle at 144, because remember, this is where they're equal to. This would make the original equation equal. I'm gonna have an open circle there, okay, because it does not show that m could be equal to 144. This one is not eating the m, which means the line will go then to the left. I think if you guys are feeling pretty good about solving equations, that this stuff doesn't become too difficult, okay? But if you're struggling with the equations, I can't even imagine the torture that this is, but math is already mental abuse to humans. So that's, on this one, we're gonna solve for x. I don't really want that 11 right there. I don't want to add it with x divided by 12. So I'm gonna zero that out by subtracting 11. But if I do it to one side, I gotta do it both sides. Remember that the addition and subtraction principles of equality will not affect the inequality. So it's going to just stay the same there. So 8 minus 11, that's going to be negative 3. The 11 zeros out just like we want, so I'm just going to drop this x over 12. And even right here where I need to multiply both sides by 12, again, it's a positive 12, so that will not affect the inequality here. But it will give us just the x like we want. And then 12 times negative 3 is negative 36. So that's solved right there. I just got to go back and then graph this. So right in the middle, I'll put my negative 36. Then I need one to the right, one to the left. Remember, it gets bigger to the left as you get more negatives, so that's going to be negative 37 on the left, negative 35 on the right. And this one is showing that the inequality is equal to the x, so at negative 36, I got a closed circle. This one is not eating the x, which means the line will go to the left. Now, I'll point this out. Some of you guys want the inequality to point the direction of the line. If you do that, remember, you always have to keep the x's on the left, so that you'd have to switch these, right? X and negative 36. As long as your inequality is still eating the same value, then you're okay. So see how up here it's eating the negative 36? When I rewrite it like this, and I gotta make sure that it's still eating the negative 36. It's exactly the same statement, just written in a different way. What about a problem like this one? No problem. Okay, we've seen like stuff like this with the equations. First thing I would want to do on this is to get rid of the 4. Now, if that 4 were negative, then I would multiply both sides by negative 4, and then I'd have to flip that inequality. This one's positive, so I don't have to worry about that. Okay, so it's still going to be a less than symbol. These 4s were going to be a phantom 1, and then I'm just left with the numerator on this, 9 plus x. I do have 4 times 15, which would be 60. One more step on this one, just subtract the 9s. Right here to zero that out, which it does. 6 minus 9, 60 minus 9 is 51, which again is not going to affect the inequality, but I'm going to drop the x. So I got 51 is less than x. And, well, now I can go to the graph. So right in the middle, I got this positive 51. I got one to the right, one to the left. To the left is 50. To the right is 52. Now this one, it's not equal to the x, so at 51, I got an open circle, which again indicates that 51 would make the original inequality false. This one is eating the x, so the line will go to the right. Boom. All right, this one's a nice two-stepper on this one. So I don't want the 14 with the negative 8x, so I'm going to zero that out by subtracting 14 from both sides. And again, subtraction does not affect the inequality, so that's just going to drop down as a greater than symbol. I'll also drop my negative 8x. We did zero out the 14 as planned. 46 minus 14 is going to give me 32 here. And then just divide both sides by negative 8. Now I said just divide both sides by negative 8. But remember, that's kind of the key point on this, in this whole lesson, is that since I divided both sides by negative 8, or that the coefficient was negative, either way you want to look at it, that is going to flip the fraction right, the inequality right here like this, okay? So again, it flipped because we divided both sides by negative. That's going to be a phantom 1x. And then 32 divided by negative 8 is negative 4. So x ends up being less than negative 4. Which is important because if you don't flip it right there, you're going to have the line going the wrong direction. And then you'll have an infinite number of values that make the original inequality false, which we don't want. So I can go to my graph now. I'll put, I guess I'll write the numbers above, but negative 4, negative 5 to the left, negative 3 to the right. And I know those aren't equally spaced. That's because I don't give a crap. And on this one, I got an open circle at negative 4 because it's not equal to negative 4. And this one's not eating the x, so that means the line would go to the left. Okay, now again, if you forgot to flip that inequality right there, you would have had the line going to the right, which would have given you all false statements. Now remember, you could check, you could say, what numbers are to the left of negative 4? Well, negative 5, right? Well, you do 14 minus 8 times negative 5, and you'd see that you'd have 44, which is not greater than, well, I'm sorry, which is greater than, what am I doing? Let's go to this one. And this one's now a multi-step equation, so I do need to distribute this negative, that's a negative 6, by the way. So I'd have negative 6 times 9x's, which would be negative 54x's. And then I also have negative 6 times 2, which would be negative 12 right there. So I'm left with negative 5 minus 54x minus 12 is greater than negative 503. So with distribution, that's done. I would look then to combine any like terms. Negative 5 and negative 12 become negative 17. Let's drop the negative 54 x's there, which is greater than negative 503. And then I want to isolate those x's, so I'd have to get rid of that negative 17 by adding 17 to both sides. So I'll drop the negative 54x. And then my negative 17 zeroes out as planned. Still not affecting the inequality, but negative 503, I should do this on the calculator. Negative 503 plus 17, gonna give me negative 486. Now the last step here for my inequality is to divide both sides by the coefficient of x, which is negative 54. And the negative part of this is going to flip that inequality there, okay? So that becomes a 1x, which is good. X is less than, though, negative 486 divided by negative 54. On my calculator, it gives me 9. So that solves the inequality, but remember, it's that last step that's a little bit different. When we divided both sides by the negative, it flipped the inequality. So now I'm ready to graph this thing. I'm glad you guys are paying attention. That wasn't on purpose, though. That's just a mistake. 9 and then 8 there on the left, right? So that'd be 10. That's better. All right, so open circle at 9 still, and then, yeah, this one is not eating the x, so the line will go to the left. All right, so on problems like this one, you got to be careful because some of you, I think, know that you can just change the signs on the inside of the parentheses. I think most students benefit if you see this as -1 that you're distributing. Okay, however you look at it, as long as you get the correct answer, that's all we care about. So I'm going to distribute this -1 into the parentheses. Remember, distribution is multiplication, but I'm not multiplying on both sides. So this distribution will not flip the inequality ever. So I got -1 times 3a's, which would be negative 3a's. And then -1 times positive 5 would be -5 right there. This is greater than or equal to 133. Now that the distribution is done, I would look for combining any like terms, but I don't see any. So I'm going to go straight to my principles of equality to isolate my a's, and I would want to get rid of that -5. So I'm going to add 5 to both sides to zero that out, which it does. I'll drop my -3a. Now again, the addition principle of equality does not affect the inequality. But 133 plus 5 is 138. Last thing here is to divide both sides, and this is important. I'm going to divide both sides by -3. Since it's a negative, I will need to flip the inequality here, okay? So that becomes 1a, just like we wanted to. And then 138 divided by -3 is negative 46. Now that I have the inequality, I'm ready to graph. So, right in the middle, see if I can do it right this time, but to the left will be the bigger negative, -47. To the right is -45. Almost did 48. So the circle at -46 will be a closed circle because we see that it can also be equal to -46. So 46 would make the equation true, or the inequality true. And this one is not eating the a, so the line will go to the left. And that's it for the graph. So there's our objective. We need to be able to solve and graph inequalities in this very short unit, which is only 2 lessons long. So that means next time we got a lesson, and the time after that will be the unit quiz. You can call it a test if you want to.